Yes, hi guys. So today I'm taking 100 lecture series number 100. Now in this case, I have to talk about what is area of surface. Area of surface in this case, not of rotation, not by revolution, but in case I'll take some questions on volume and surface area based on rotation also. But in this case, I'm taking double integration. With the help of double integration, I've discussed something in multiple integrals. Okay, in multiple integrals, we discuss about double integration, triple integration, etc. But in this case, I'm taking only double integration. Now, in this case, double integration, we have to find out what is surface area of a given surface. Okay, with the help of double integration. Now, in this case, suppose your function fx by equal to z or z equal to fx by is given. Okay, now in this surface we have to find out, and suppose we take an elementary element, okay, a p point. Let me take p x by z, the point in this surface, and around this p point there is a elementary space. Let me take this is delta s. Now delta s element, we have to now put a projection of this area. Now projection of this area upon the z equal to 0 or xy plane. Now xy plane is z equal to 0 undoubtedly. So upon xy plane we have to do a projection of this space or this surface delta s. So let in the xy plane this surface area of this elementary surface or elementary area delta s is delta x delta y. Okay, and then we will consider that what is the length of this, okay, or what is the area. I mean relationship delta x delta y equal to how much? Delta x delta y equal to delta s into cos alpha in this case, where alpha is the angle between. Let me write down this and explain this whole. Now from first to 5 questions, I'll take on the surface area with the help of double integration. Again, I'll take these formulas with the help of volume, surface area, or volume of surface of rotation, volume of solids of revolution. So this is 6 onwards. I'll take questions, some remaining questions which were based on volume of solids of revolution, okay, or surfaces of volume, surfaces of revolution, that I have to discuss. Or some questions are left over from previous lecture series, so that I'll take. Some more questions were asked by the students, so I've taken them with volume of surface of revolution. Okay, so that is question from 6 onwards up to 13 questions. 7 questions I've taken more based on surface area, surface of the surface of rotation and volume of rotation. Okay, volume obtained by revolution of a surface area about an axis or about a line. Okay, so there are 2 questions from 6 onwards, but up to 5 let me take with the help of double integration. What is how to solve the double integration? Let me define this definition. This is area of surfaces by double integration. Now in this case we will take let z equal to fx by be a function of the plane okay, of xy plane. Here z is defined in terms of x and y. That means let me take this is z axis here, O, this is x axis, this is y axis here. Okay, so this is xy plane here, x by z in this case. This is y axis, this is x axis, z axis. Now if I take an elementary space, let me take this is a P point here. This is point P. This is P point is there, and P point coordinates having x, y, and z. So this is x by z. Triple, 3-dimensional geometry in this case. To P x by z, we have taken a point. Now this ds or delta s, let me take. This is delta s here. Now delta s is the area of this space. Let me take of the plane. Let p x by z be a point. Let me take a point in in the plane, or in this plane z equal to fxy, in the plane z equal to fxy. Now delta S be the surface or area of the surface. This is area of the surface here, area of the elementary surface. Delta S be the surface of or area of the surface. Let me take here. This is I've written down here. This is here. Be the area of the surface. Okay. Be the area of the elementary surface. Let me take elementary surface surrounding P. Surrounding P point, surrounding P x by z point. Surrounding the point P, I have taken this surface. Okay, now if I drop a projection upon the plane z equal to 0, this is z equal to 0 here, and let the area of this plane is delta x delta y. This is delta x delta y here, area of this whole space, which is the projection of the plane area. Okay, so then, and let us take pxy, and delta x, let me take here, this is the point surrounding px by z. Then the projection of the elementary space delta S on the plane z equal to 0 be delta x delta y. Elementary space delta S on the plane z equal to 0 be delta x delta y, because here z equal to 0, but this plane is xy plane, so area of this plane is delta x delta y. Okay, and then delta x delta y is equal to delta S into cos of alpha. Why cos of alpha? Let me just define it. Cos of alpha, where alpha is the angle, between, here this alpha is the angle between, if I drop a tangent like this, okay, or is the angle between this, okay, or but this is here angle alpha. So angle alpha is the, where alpha is the angle between the tangent, plane at the space at the delta S surrounding P x by z, and the area delta x delta y. Then this I have defined here, delta x delta y is equal to, this is the base here, value of the base is delta s into cos alpha. Okay, or we can, this implies that we can write it as delta s is equal to, this is secant alpha, this cos alpha will be divided by delta x delta y divided by cos alpha, it will give us secant alpha into delta x delta y. Okay, this is, let me take first equation. Now from geometry, coordinate geometry, we know that what is in three-dimensional geometry. This are discussed in three-dimensional geometry. We see my coordinate geometry that are discussed about that second square alpha is equal to 1. This is second square alpha is equal to 1 plus del z upon del x whole square. The del z upon del y whole square. This is delta z, del z upon del x whole square, delta y upon del z, or second alpha is equal to square root of this whole value. This is 1 plus delta z upon delta x whole square plus delta z upon delta y whole square. Now if I substitute this value of second alpha in this equation 1, this is suppose second equation here. So from first and second we get, what do we get here? Delta s, the area, small area, delta s equal to, this is second alpha is this value equal to under root, this is 1 plus delta z upon delta x, this is partial differentiation, plus delta z upon delta y whole square, whole delta x delta y, this value. This is second alpha value which we have taken from equation number 2, this one. In the first one we have substituted, so this is what we have obtained now. Therefore, if I integrate this, put the double integration, because this is delta x delta y. Therefore, area, this is area here, delta s is in this case capital delta s. So therefore, area of the surface, okay, s equal to area of the surface, that is s equal to here, this is sign of double integration we will substitute here, this is delta x delta y, therefore we can write it as under root 1 plus delta z, or sorry del z, this is del z upon del x whole square plus del z upon del y whole square, okay, within curly brackets let me write, this is dxdy. Here limits for x and y will be taken from the projected area, this one, okay, and where the limits of integration, with the limits of integration will be taken from the area of projection. The area of the projection means this is the area here, x and y. From this area we have to take the limits. Area of the projection or projected area. Area of the projection. So limits we will take from here. Now questions based on this question are from 1 to 5. I have taken these 5 questions. Let me first complete, because these questions are taken from the student queries. Okay, so they are based on this formula only, and limits are just defined that how to take the limits here. So limits for integration, and this is the process of this. So there's the volume of surface area. I mean, this surface area we have to find out this s, but this is given by this projection, and the limits are taken from this projected side. Projected side will give us the limits here. Okay, so this is the formula we will apply for this area, for surface area, projected surface area, with the help of double integration. Now let me take questions one by one. In first question, let me take question number 1. It says find the area of the surface of the paraboloid AZ equal to x square plus y square, which lies between the planes z equal to 0 and z equal to alpha. Okay, we are given z equal to 0 and z equal to alpha here, no problem. So let us take what is the possibility of this. Now in this case, okay, area, question number 1 here we have taken. In this case, the curve, the paraboloid is AZ equal to x square plus y square. AZ equal to x square plus y square. Now in the plane z equal to 0, okay, z equal to 0 and z equal to a we will substitute here. then we will find out value of x. So here let me differentiate. This is first equation. Solution. Now let me find out. Okay, so this is a parabola here. So we will substitute then value of z equals 0 and z equal to a. From there we have to find out this value. So x square plus y square. If I put z equal to 0, then x plus y is equal to 0 here. X equal to y equal to 0, x equal to 0. X equal to 0 to a here, we will take the limits. And y equal to, we have to take, this is a square minus x square. That is the limits for y. So let me take first here. Here, a z equal to x square plus y square. This is first equation we have taken. Differentiating partially, differentiating it partially with respect to x, first x and y respectively, and x and y respectively. First a into del z upon or delta z upon delta x is equal to, this is twice x only. Why y is 0 in this case? We are differentiating with respect to x partially, then y is considered as constant, which is there. Therefore delta z from delta x equal to twice x upon a. This is first part. Sorry, this is second equation now. Value of delta z del x and del z del y. If I find out, this is a here, a into del z upon del y is equal to, this is twice y again. This implies that del z upon del y is equal to, this is twice y upon a here. This is, let me take third equation. Therefore, now in this case second alpha is equal to, therefore second alpha is equal to under root, this is 1 plus, okay, so this is 1 plus del z del x whole square plus del z del y whole square is equal to, let me write, so it will give us 1 plus, this is twice x upon a, this is 4x square upon a square, so this is 4y square upon a square. Okay, so if I take 4 common here, a square is LCM, this will give us a square plus 4, let me take x square plus y square divided by a square here. This is nothing but 1 upon a under root, this is a square plus az here. Because x square y square equal to az, in this case it is az here. Okay, or this is, let me write 4 into x square plus y square. Now if I convert this into, okay, polar equations, if I convert this into polar equation, then x square y is equal to r square. This is r square here, a square plus 4r square in this case, and this a square equal to, then, because in that situation if I put here polar equation, polar coordinates, so x equal to r cos theta, let me take x equal to r cos theta and y equal to r sin theta. If I take this equation, okay, let me change the marker. It's just creating the problem here. Okay, so it means we have to just substitute. Now what are the limits for then r and theta here? So we will get here x equal to a and then limits are there. Okay, so the question is 0 to r equal to 0 to a, we have to take here. The point is, so we have to convert this into polar equation. That means convert them into polar. So this is x equal to r square. Here it is a square plus 4r square, because x square plus y square, therefore x square plus y square equal to r square. If I substitute this value here, it will give us under root 1 upon a, within bracket it is a square plus 4r square upon a square a square I have taken out, fact only this is a square plus 4r square. Okay, and what are the limits here? If I put value of this x equal to 0, so x 0 to a here, theta is 0 to pi by 2. Why? Because x 0 and theta equal to pi by 2, and x equal to a here, 0 here, or r here, then r equal to, so r equal to 0 to, first theta let me take 0 to pi by 2. Why 0 to pi by 2? That 0, or if I take x equal to 0 here, then theta equal to pi by 2. The limits are, negative sign will be there, but no problem. Here limits for this is, limits for r, because in this case this is r equal to 0 to a here, because x square plus y square equal to r square in this case, and this r square equal to 0 to a, because r, this is r square equal to a square here, because we have x square plus y square equal to, if I put z equal to a in this case, it will be a square, then this is r square equal to a square. Limits for r are 0 to a, and for theta it is theta equal to 0 to 2 pi. Why theta equal to 0 to 2 pi? Because in this case the whole sub area is to be taken as area equal to 0 to 2 pi, because theta in this case cos square theta equal to r cos theta equal to x, and if I substitute x equal to here, if I substitute x equal to cos theta here, so that will be limits are 0 to pi by 2 theta. Why? Because in this case changing to polar coordinates, we have changed the polar coordinates. So in this situation, and r equal to 0 to a. Okay, so a square, this is a square plus 4r square here. Now let us say, and here this value will give us a square plus 4r square. Alright, so a square plus 4r square whole power 3 by 2. Okay, so this is in terms of, now let me take the area then. Therefore area will be, I'm sorry, I was just removing this dark here. So in this case, what is the area thing? So this is the value 1.a under root a square plus 4r square. Now if I substitute this formula, therefore the area of the surface, therefore area of the surface here, we have to find out here area of the surface lying between z equal to 0 to z equal to a. If I substitute z equal to 0, that means r equal to 0 here, and if z equal to a, okay, then a square equal to r square or r equal to a. So this is r equal to 0 to a limits, and when r equal to 0, we have substituted here. So in this case, 0, theta is 0 in that situation. Or if I put y equal to 0, then theta is 0, and if I put y equal to, in this case r, so r is equal to 1 here. Or in this case x equal to 0, then theta is theta equal to 2 pi in this situation. Because theta in this y we have to substitute first 0, then theta is 0, and y equal to 0, so y equal to here r here, so r is equal to 1, theta equal to in this situation y equal to 0, then cos theta is equal to pi by 2 plus minus pi by 2. Okay, and but limits in this case is not the one arc here, the whole surface is there. This is surface area. Okay, area of the surface, therefore area of the surface equal to double integration. This is theta equal to 0 to 2 pi and r equal to 0 to a. These are limits. Now integration sign, because this is 1 plus, this is a square plus 4r square upon a, 1 upon a we have taken here, and this is r d theta dr. Why? When we convert them into polar coordinates, I have described in multiple integrals. In multiple integrals, dx dy equal to r d theta dr. This we have defined in multiple integrals. Okay, as we know that ds dy equal to, so in place of ds dy we have substituted d theta dr or r d theta dr. This is dr here. Okay, so in this case first we have to integrate this with respect to r here. Okay, that means here if I take 4r square or r square equal to something, or let me take 4r square, a square plus 4r square equal to t, then what is that? So putting here, let me integrate with respect to r here, putting a square plus 4r square equal to t, let me take. Therefore 8 into r into dr equal to dt, differentiating it with respect to first t, differentiating it with respect to t. So we get here 8r is constant, so this is 8r into dr equal to, or dt is this, or r dr equal to dt upon 8. This is value of r dr here, r dr, this r dr, d theta will take later. Okay, so that is the, so under root t we have taken. So that let me take here 1/8, this 1/8 we have taken out. Here it is 1/8. Sin of integration g theta equal to 0 to 2 pi. And here it is r equal to 0 to, let me first write 0 to a here we have taken, and this 1/a also we have taken. So this is 1/8a. 1/8a I have taken outside. Now this is t whole power half into dt. For dt upon 8 I have taken. Limits also I have to change, because a square plus r square I have changed here limits to dt. Okay, or if I just convert this after integration, if I convert then put the limits the same value, then put a, that will be okay. Now let me first integrate this with respect to t. Then limits are for 0 to a, I am not changing. If I put here r equal to a, it will be 5a square. Okay, 5a square it will be done. That can be done, limits can be changed, and 0 if r, then t is a square. A square to 5a square, that will be, that is not a problem. So if I put here, let me take t equal to, in this case, a square to 5a square. That can be done. Therefore this is 1/8a, and this is d theta also, I'm sorry. Now this is first we have converted into t. It is integration is now theta equal to 0 to 2 pi. Now here it is t raised power 3/2 upon 3/2 means 2/3 here. Now limits are to put a square to 5a square. Okay, so this is the value of t we have taken. dt is equal to, okay, so now this 2/3 also we can take outside. It will be then 2, 4, so it will be 1/12a, 1/12a. This is now theta equal to 0 to 2 pi. Okay, now this is substituting the value a square into, or a to 5a square. If I put 5a square here, so 2 cancel out. So 5 raised power 3/2 we will take. 5 raised power 3/2 we have taken outside, and aq will come out. It will be aq then minus, here a square, if I substitute this will be aq only. 5a square whole power 3/2. Okay, this is 5 times a. Okay, 5 raised power 3/2. That means 5 under root 5 minus aq only, is 5aq minus aq only. aq if I take outside, let me take it outside, it will give us, it is equal to 1/12a. Alright, aq I have take outside, let me take, and this is now theta equal to 0 to 2a. The left over term, this is 5√5 minus 1 only into d theta. Now d theta. only d theta here. The d theta now left over. With respect to t, we have integrated. This is now open. AQ we have taken out, as this is a square upon 12. Okay, now so at 2a, theta is 0 to 2a, sorry, 2 pi here, I'm sorry, 0 to 2 pi in this case. So if I integrate this, it will be 5 under root 5 minus 1 into theta. Now limits we have to substitute 0 to 2 pi. Okay, so it will give us a square upon 12, in bracket it will be 2 pi into 5, and the second will be 0, 5 under root 5 minus 1. This is the value here. So 2 pi means 6, a pi a square upon 6 under root 5, 5 under root 5 minus 1. So that is the answer here. Finally, what is the answer? In this case, we get answer as this 2 pi, I will take outside, this is pi a square upon 6, within bracket it is 5 under root 5 minus 1, this is the answer here. Okay, so area of this paraboloid is this much. Question is, okay, just a tricky one, just we have to apply the formula. What is S surface area? Surface area by double integration is given secant alpha, if I write here secant alpha into dxdy. Limits we can take from the projected side. Projected side, they say z equal to 0 and z equal to a, we have to substitute, and we have converted that into polar coordinates. Because the polar, after changing into polar coordinates, then the question was solved. This is the answer here. Pi a square upon 6 into 5 under root 5 minus 1. Okay. This is the formula which we have to apply for the surface area. Okay, in this case, secant phi and root 1 plus del z upon del x whole square plus del z upon del y whole square, if the xy plane is given. Z equal to xy plane is given. And limits for x and y are taken from the projected side. But in this case, z equal to 0, z equal to a were given here. We substitute here z equal to a, then r square equal to a square in first situation, and when z is 0, r square equal to 0. The limits of r were 0 to a, and for theta we have taken 0 to 2 pi, because this is the whole space given to us. Area of the surface of the paraboloid, because in paraboloid case, the whole parabola is taken, so this 0 to the whole curve is taken. Okay, now let's take next question. This is the answer of question number 1. Now let us talk about second question. What does question number 2 say?